Yeah, my name is Nasari Catherine, and I'm going to be taking you through machine learning deployment. So, how did we come up with our machine learning model? First, we collected data. We got images of tires for both good and defective tires. Now, from these images, we trained 10 models. Among them, there was the contrastive learning models using CNN. We used pre-trained contrastive learning models like ResNet. And yes, from there, we used the knowledge distillation amongst these ones. So the best performing model was the one we deployed, and that was the mobile VNet model. So from these 10 models that we had, we evaluated them using validation accuracy, F1 score, precision, and learning rate. Yes. So now, from this, how did we come up with the deployment steps? We started with virtual creation. Through this virtual environment, we installed all the requirements needed for this model to run. And from there, we used Flask and all those other TensorFlow to, to build this model. Yes. From there, we used Streamlit. Streamlit provided the user interface for our model that was created. And from Streamlit, we deployed our model using on Hugging Face.
All right. My name is Luganzi Matthias, and as my colleague has talked about the app and UI development, so we started by creating a virtual environment where we could do the development of the UI and the application. Yeah, in that we made installations of the necessary files that we needed. For example, installing PyTorch, installing Streamlit, and all other necessary installations. We moved on to create the app. So we create the app.py that contained the Streamlit files. So this file contains all the necessary files to make sure that our application runs. So in this, we had a Streamlit file. The Stream files were used to create the app UI, whereby you could upload the image and then loads the image into the model, and then the model is able to process it and give output. So all this is done by the Streamlit files, as we shall see. Then we tested the application using Postman on the local machine. So after developing it, we had to test to see if it's working. And to do that, we had to run it the local server and then use Postman to see whether it can actually run and give output. So if it does so, if it works, then you know you're sure it will work anywhere else when you deploy it. And if it doesn't work, then you have to fix those specific errors that will show up when you try to test it and run. So after that, we moved on to the deployment part, where we were supposed to uh, create the model deployment. We integrated the saving model with Streamlit files into the app.py file, and then it was able to become one application that could run and give output while using the user interface. So you went on to create a space on Hugging Face. So on Hugging Face, that's where we actually deployed our model, because reason being gives you a lot of RAM and about 2 CPUs to 4 that you can use as a free version, unlike other hosting services like Render, where you only have about 512 MBs of RAM, which is a little bit limited for people with models working with image datasets, since our models tend to be big, about 50 MBs, 45 MBs, and some have bigger, almost 100 MBs. So, like I've talked about creating a space on Hugging Face. So you come to new space, then you're able to create a space. You enter in the module name, maybe tire defect detection. Okay, then I'll choose the description. I'll give it I'll select the SDK. I select Streamlit because we're using Streamlit files. And then for the uh hardware, you choose the free instance, you make your project private, and then you create a space. So after creating the space, you can clone the files, and then you're able to get a space where you can actually upload your files. You after cloning, you upload. So I uploaded our update py file, and as you can see, we're importing Streamlit files up here. So you import the Streamlit files. Then after you import the PyTorch, you load the model. You can see we're loading the model right here. You specify the model path, and then it prints out the model is loaded successfully. And then you transform the images after they have been loaded, reduce their size because we're using very high quality images. Then after they are fed into the model is able to make the prediction. Yeah. So I think that's all for the files uploaded. And then we also upload the model and the requirements, the txt that contains the model files and the dependencies that are required to make our model work. So let alone when I try to learn the application here, I can browse for an image. I can choose a good image here. After choosing the image, it's loading. After loading, to be able to be displayed down here for the user to view. So remote the image is displayed, so I can click predict, and it gives me output as a good tire. And since the tire was originally good, yeah, I can preview that the model is working properly. Then I can go ahead and choose a defective tire. So I've chosen a defective tire. I want to try out and see if it also works. Yeah. It's loading the image, and in a few it will begin to display it down here, and then we shall be able to predict its nature. So image is displayed, you can see it has cracks and all that. So model declares it defective. I think that's all about the Mlops. I think we catch up in the next demo if at all any happens. Thank you.